guys, welcome back to Digits. Today we're going to be talking about Chapter 10 and Part 3. Yesterday we dove a little bit into equivalent ratios, and we're going to get a little bit deeper as this unit progresses. So let's talk about the equivalent ratios. Copy this question into your notebook. This is like a essential question. How is it possible for two different ratios to describe the same situation? And what does it mean for two ratios to be equivalent? Okay? You don't have to answer them yet, but I do want you to leave some space below the question so that way at the end of the class you can answer it, okay? Copy this part into your notebook. I want you to copy down the phrase and the two number lines. You can use double number lines to find equivalent ratios. The first number line they have listed is counting by ones, while the second one is counting by twos. So for this ratio, it is a 1 to 2 situation. For every 1 on one line, you have 2 on the other line. That's why the 1 and the 2 are lined up perfectly. Same with 2 and 4. For every 2, you have 4. That goes from 1 to 2. Okay? And that's going to keep progressing as you go up the number lines. Copy down what you see here, and then push play when you're ready. Okay, so from where you just finished taking your notes, I want you to draw a line to separate this next part. Copy down the question. Use number lines to find the ratio equivalent to 8 to 10. So you're going to need to draw two number lines. Okay? We'll make them positive number lines just to make it a little bit easier. So put your 0 at the end and do positive numbers. Okay. And about where 8 is located on one number line is where 10 is going to be located on another number line. 7, 6, 5, 4, 3, 2, 1. Alright, so 7 is going to be about right here. 6, 5, 4, 3, 2, and 1. We're trying to find a ratio that is equivalent to 8 to 10 with lesser terms and one ratio with greater terms. Okay? So we do on the right side of it as well. 9, 10, 11, 12, 13, 14. 9, 10. Okay. So, we know that for every 8, there are 10. But what if we were to divide 8 by 2? What would that turn into? 4. And what if we were to divide 10 by 2? That will give us 5. So on our 4 is where our 5 is going to be aligned. Okay? The other ones aren't going to be exact on the number line, but we do know that we're going to divide those two numbers. Now, what if you were to multiply these two numbers? What if you were going to multiply 8 times 2? Well, that'll give us 16. So here somewhere. And 10 times 2 will be 20. Okay? All of those are the same ratio. Okay? And you'll just fill in the numbers in between where those ratios are going to be. Let's move on to the next part. Alright, so this is kind of like what we just did, but it's explained a little bit differently. Here's a line to separate what you did from what you're about to do. You can find equivalent ratios by multiplying or dividing each term of the ratio by the same non-zero number. All this this right here is just a fancy way to say, if you divide one by a number, you have to divide the other by that same number. For example, if you wanted to split this ratio in half, if you wanted to make a simpler version, you would divide each of the numbers by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. That would be the same as saying I'm going to divide this ratio in half. So now I have a 1 to 3 ratio. That's what this guy says. Okay? What if I wanted to make a ratio larger? Well, you would look at your original number, which was 2 to 6. And as you see, you have 2 circles to 6 squares. Well, if you wanted to double it or triple it, you could do that. But if you were to double it, you would multiply 2 times 2, which would be 4, and 6 times 2, which would be 12. That's the same as saying I'm going to take this and then draw it again down here. That's what happened on this situation. You're going to copy down these 3 diagrams underneath the question. Ooh, excuse me. I don't know why I skipped. Go back again. Sorry. You're going to copy down these 3 diagrams underneath your question, and then I want you to push play when you got everything copied down. Okay? I know you know it's on the next slide. Alright, you don't have to copy this one down, I just want you to pay attention and listen. Okay, I'll do this one in blue. A volunteer at an animal shelter reported the ratio of the number of dogs adopted to the number of cats each month. She finds all the ratios are equivalent. Complete the table. So, essentially we have 4 dogs for every 5 cats that are adopted, also known as 4 to 5. Okay? In February, the number of dogs doubles. We know this because 4 doubled is 8. So what would 5 doubled be? Well, I hope you know by now what 5 doubled would be. That is 10. Okay? So 4 times 2, 8. 5 times 2, 10. Alright? What about what's happening in March? Well, it looks like the original ratio tripled. 4 times 3 is 12, so 5 times 3 is going to give you 15. Okay? Once you figure out how to do this, guys, it's actually very simple. It's just a matter of practicing so you understand what it means. Alright, so I don't want you to write a ratio. I want you to write some ratios. And what I mean by that is I want you to create a either a word cloud or a text box. I like to do word clouds. Okay? And I want to write some ratios that are equivalent to 3 to 4. Okay? Yesterday we created a multiplication table to kind of help us figure these out. Or you can just do this in your head or on your paper. 3 to 4 is as simple as it's going to be as a whole number. Okay? I'm going to use black because I'm feeling kind of Valentine's-y. So what if I wanted to double 3 to 4? Again, if you're going to double it, you have to multiply both numbers by the same amount. 3 doubled would be 6. 4 doubled, well, if you guys know that by now, is 8. 6 to 8 is the same thing as 3 to 4. Okay? What if you want to triple it? That'd be 9 to 12. I want you to create at least 3 equivalent ratios to 3 to 4. When you finish, check with the neighbor and see if they got it right. You don't have to have the same ones. I mean, you can make them as complex as possible if you want to. Just make sure that your neighbor is right, so that way to see if they understand what we just did. All right, now I have whiteboard time. If you don't have a whiteboard on you, just use a marker on your desk. If you were to make a playlist with 6 hip-hop songs and 9 pop songs, 6 hip-hop songs and 9 pop songs. All songs play for the same length of time, so they're all probably like 3 minutes, 20 seconds, or something like that. Now you want to make a longer playlist and a shorter playlist that each have an equivalent ratio of the number of hip-hop songs to the number of pop songs. So look, hip-hop is first listed to pop songs. So first you want to write what the ratio is going to look like by itself. All right, 6 to 9. For part A, we have to figure out how many songs of each type can you put on a longer playlist. It has to have the same ratio, like 6 to 9, but it needs to be a little bit longer. Okay? Well, use your chart or your number line and find 6 and find 9. What is a greater ratio? In other words, a greater number that's the same equivalent ratio. Well, you can do, looks like 12 to 18. I will do that one. And to see if it's correct, you need to look at your first numbers. I did 12. 6 times 2 is 12. And we talked about if you multiply one thing times 2, you have to multiply the other times 2. 9 times 2 is going to give you 18. So now you know that you've made a correct ratio. Now let's go to part B. How many songs of each type can you put on a shorter playlist? So now we're trying to make the playlist a little bit shorter. It has to be the same, like an equivalent ratio. So we know if it's going to be shorter than 6 to 9, or it needs to be a division problem. You're going to divide 6 by something and 9 by something. So I'm going to choose an even number. I'm going to choose 3. 6 divided by 3 will give me 2. And 9 divided by 3 will give me 3. Okay, all of those are equivalent ratios. Oh man, my nose is stuffy. Alright, use the ratio table that you were given to solve this problem. When you think you found the answer, I want you to get a teacher to check and make sure you got it right. Write 2 different ratios that are equivalent to 4 to 10. Alright, that's simple enough. So what you're going to do with your neighbor is you guys are going to figure out what a similar ratio or equivalent ratio, would be to 4 to 10. Okay, when you guys think you've figured it out, I want you to check with a teacher and see if you got the correct answer. I am not going to tell you what the correct answer is in this video. So definitely see if you got it right. Okay, so I want you to go back to your first question. Similar to this one, what does it mean for 2 ratios to be equivalent, and why might you want to use an equivalent ratio? Okay, I'm going to go back to the old pizza method that I've been talking about quite a bit, and let's think. If your pizza was not split into 2 pieces, if it was split up into multiple pieces, how would you know if you have a fair amount of pizza in case you had to share it with somebody? Okay? That's one situation that we see it a lot in real life. If you're trying to split something, how would you know if it's going to be a fair split? Alright? What does it mean for 2 ratios to be equivalent? Put this answer in your own words. When you think you found your answer, I want you to get a teacher to check it. Also go back to the very beginning and make sure you have those answered as well. Good luck on your digits. I hope you have a wonderful day.